In this video, I am going to be talking about function template and class template. Templates are the tools to create a generic code, a code or logic that can be used for or applied to different data types or different types of data. Suppose you have a code or logic, and that logic can be applied to data of different type, which results in different realization of the logic execution, and it results in different output. Now this behavior, this different realization of the logic execution and different output is a behavior, and this change of behavior of the code for different data type is essentially a polymorphism. So this template enabled polymorphism is called generic polymorphism or parametric polymorphism. From the coding perspective, generic polymorphism is a function or class taking different forms or behaving differently for different data types or different types of data. Now let's get into the coding for to explain it further. This is the coding space I'm going to use, and first I will explain it through a templated function for adding two numbers. For adding two variables. Suppose I have two integer variables, int x initialized to 5 and y initialized to 6, and I have another variable z to hold the result of adding the two variables x and y. That means the result of the addition of x and y is going to be stored in z. So I want to have an operation something like this, right? I want to have a summation function or logic to add two values and return the result to be stored in z, and afterwards I want to see the output summation displayed in the output terminal. Now for that I would create a function called sum, and I would make it receive integer type variable a and integer type variable b, and I would have this function returning integer type data, and inside the logic I'm going to have is going to be something like this: int c, and c equals to a plus b, and I return c. This is the logic I have inside the function. So now this function should execute. Let me show you the function execution. This is going to be the the name of the source code. The file containing the code is main1.cpp. The output file is going to be main1.exe, and compiler C++ 23 standard I'm using, and this is for displaying all the warnings. Let me compile and link this program, and let me execute main1.exe. So now we have the data displayed, sum equals to 14, which is the addition of 5 and 6. It's working perfectly. Now let me have a different type data, double. Let's say m equals to 5.5, n equals to 6.6, and O for holding the result of summation in this case. And I want to have code like this. I want to add m and n and store the result in O, and I would like to actually display the result. Right now I would now this will actually call the same function. Let me first make sure that it executes. In the output terminal is executing without problem and running, and it's displaying the data 11. So definitely we wanted to add 5.5 and 6.6, which would result in 12.1, I guess, but it resulted in 11. And what happened is it used the same function, but it actually implicitly it converted this 5.5 into 5 integer type, 6.6 into integer type 6. So it added 5 and 6, and the result was 11, which is what we don't want to happen. So if we want this type of this variable double or fractional component to be preserved, then I would need to define another function with double type data parameters, and it would return double type data, and I'm going to have the logic pretty much similar to the logic in the previous function. So if I have this function defined for double type, let me correct this, this should be C, then I would have the output displayed correctly. So now we have 12.1 as the output of the double summation. Now if I want to have summation of a different type, let's say string st1 or s1 hello, s2 world, and s3 to hold the result of addition. S3 equals to summation s1 s2, and let me display this sum s3 and L. Now since this function is not defined for, because there is no way of implicitly converting like in the previous case, there was C++ has a way of implicitly casting double into integer type, so by truncating the fractional part, of course, but there is no implicit way of converting this string type into either double or integer type, so it is actually complaining, right? There is no function that matches the parameter types. So you need to define in this case similar function but with different parameter type. Now with this change, it should not be illegal anymore into the compilation and execution. Now the two strings are actually added, concatenated, and hello world is displayed, right? So now this S3 carried the concatenated version of S1 and S2, and it displayed. Now the reason it is concatenated is that for a string type this addition operation is defined to actually concatenate the strings. Now if I don't want, if you don't want this much code, this many code, but if you want to reduce the amount of code in this particular situation where we have the same logic, you can see the logic is pretty much same, exactly same, but only difference is the type, right? So if you want to create a code which is actually generic enough but only difference in the type, then what you can do is replace this type by some something, let me call it T. Now you can see that this code is a generic version of all these three different collection. You can call this as a collection of functions, a collection of logic, but you can call this as a generic version. And in C++, template is a way of creating generic code or generic function. So the way of creating generic function is you must have these keywords called template and followed by angle bracket. Inside angle brackets you have either class T, or you can also have type name. So this type name is a more frequently used term in this case. I prefer this keyword type name. Now this is type name will make this T as a type parameter. That means this is a parameter to replace the type. When we actually use this function, this T is going to be replaced by either integer, double, or string. So if you replace this T by integer, this function will exactly become this function. If you replace this T by double, then this function will exactly become this function, double function. And if you replace by a string, it will become this function. Right now, if we have this function, this is a templated function, this is generic function, it represents the collection of these classes, this functions, collection of functions, right? With this templated function, we don't need these definitions anymore. You can remove this things here, right? Now we have this templated function, and whenever there is a call to this function, it will look into the compiler will look into the type of the data, and it will actually replace this T by the type of the data and create this version of this function itself. And at this point, compiler will actually see that the type of the data being used is or arguments being passed is double, so it will replace this T by keyword double and create this version of the function. And at this point, compiler will actually create the version of the function for string type. Exactly this kind of code. So now with this we have a templated function which is going to behave differently based on whether integer type data is being passed, or the double type data being passed, or the string type data is being passed. The reason I call it behaving differently is, even if the logic is same, but the way in which this addition operation is going to be executed for integer type and double type is going to be different, because integer data have efficient way of, there is a one algorithm is used for integer addition, which is efficient, more efficient than the algorithm that is actually will be used for double type data. Double type addition is more expensive, right? So the way data is added for, obviously in the case of a string, it's going to be implemented differently. You can see in the case of a string, it is concatenation. So even if this logic looks same, but the way the details of this logic is implemented will make it behaving differently for different types. So in that sense, it is a polymorphism. So in this case, the templated function is behaving in one way. In this case, it is behaving in different way. In this case, it is behaving in different way. Let me make sure that this code actually runs. There's no problem. So let me again compile and execute. Now the data is displayed is exactly the same, right? There's no change. Now after this, let me comment this out for a moment. This let me have three versions of this function. For example, if I have my own type, instead of using the type that is available through the library, let me create my own type called point to hold x and y values of a point, right? This is my type, and I want to create the 2 point objects in this place. P1 equals to 1 2, P2 equals to 2 3, and P3 to hold the result of summation. And if I want to use this summation function in this case, and I want to actually let me just stick to this now. So this is obviously invalid because this function is not defined for point type. So let me define this function with the same logic for point type. Now you can have the similar function overloaded. Now this is at least okay, but now still there is a problem because you cannot use this function because you need to, all the operations that are involved inside the logic have to be valid for this type. There is no addition operation defined for point type objects, right? So therefore, if I try to compile, it will obviously complain. You can, if you can try yourself, but I'm actually giving a solution in this case. You need to define, if you want to use a particular type for this logic. Particularly, it's important because if we are using the template for different type, then the same logic is being used for different types. So if you want to use template function, you need to define all the operations that are involved in that logic for that type. So let me just focus on this one, this this function. This addition of 2 point object has to be defined. Okay, so the way you define that addition is going to be you overload the operator, addition operator, point object. Let me make it constant, P1. Sorry, let me use the same parameter name, B, P dot x equals to A dot x plus B dot x. I am actually adding x coordinates of 2 points to x and y to y. P dot y equals to A dot y plus B dot y, and I return P. So this is the operator I have defined with this definition of this addition, because it will actually receive 2 point type objects, perform the addition and return that point type object. That is what actually is required in the addition. Now in this case this addition looks to be valid. Okay, but assignment is okay because when a point object is assigned, then the parameters are assigned one by one, so you don't need to, in this particular case, you don't need to explicitly define assignment operation. So now this code should execute with a problem, but I want to make sure, because I don't want to make any assumption in this case. So I need to make sure that code is okay. Now there's issue, there's problem. Let me try to fix it. No matching function for this reference call sum. This is unused variable. I think there's some issue with the code. Let me go and see. This should be P2, and another issue was maybe that was the issue. Let me try to compile. Point doesn't, did he, oh yeah, I think let me go back to the code and see the problem. So I want to clear and see the error again. Point does not name a type. Did you mean int? All these are warnings. I think this is one the error. So line 12, so 66 and 31. So we have yeah, the problem was that this point was used, but it was defined afterwards. So because when compiler actually went to this point, it compiler didn't know what is point. Okay, so you need to tell compiler. So let me move this before here. Let me compile again. Now there is another problem. No maths for operator. A plus B, line 39. So this operator is also not known this to this sum function. So it needs to, either you need to declare it before or you need to put entire definition before. So let me put a declaration. In the declaration I don't need to have the name of the variable. So let me try one more time. Successful execution. Now it's actually displaying, it's running without issue. Okay, but we also need to see the output. So I want to actually display this P3. Right, so if I try to display, it is already flagging an error. You can see the reason is that it will not work even if I compile, because this insertion operator is not enabled for this point type object. So we need to enable insertion operator. For that we need to have overloaded version of insertion operator. Waystream object operator and waystream object, OS name of the object, constant point reference PT. Inside this operator, it has different types, so I'm going to return OS object, and you can choose the formatting style, the style you want to print. pt.x. I want to print the x and y values enclosed by parentheses. So this is the way I'm going to print. So this is enabled. So this insertion should be valid now in this case. Let me go to the compilation and execute and see the output. So now the added point is displayed 3 and 5, and it was a result of the addition of 1 2 1 plus 2 was 3, 2 plus 3 was 5. I think this okay, correct addition. Now once we have this type and all the operations that are involved in this logic are actually enabled, in that case we don't need this definition. We can use the same template function to apply. You can apply the same template function for this point type. Okay, so let me comment this sum function out for this point type, and I'm also going to comment this functions for integer, double, and string types, and have this template function. Now the operations that are involved with the use of the point type with the template function are involved are actually defined, addition, and afterwards insertion operator. So with this we should be able to execute this code and get the same output that we got before. Now you can see summation of integer 11, summation of double type 12.1, hello world 3.5. So what actually happened in this case was there were 4 different versions of the sum function created for these 4 different types by the compiler, and those functions were actually used in the execution. Now one additional thing I want to discuss here is multiple parameters. Instead of having only one type parameter, it's possible that you can have multiple type parameters, and you can have this different 2 types. Okay, so if you have different type parameters and the type of A and B can be different, in that case for example if it is integer and double, then you need to properly define this operation for adding first integer and second double type. Or if first type is the point type and second is integer type, then you need to have that defined here, this operation defined here. Okay, in this case let me use this function. If we have this double 2 type parameters, then we need to make some changes here. We can explicitly define what compiler will do is it will take the type of the first parameter, second type parameter, in this case integer, so it will replace both u and t and u by integer type, but you can also explicitly suggest the compiler to use these types, these 2 types for that particular case. In this particular case, in the previous case you would have just specify one type because there was only one type parameter. In this case you specify 2 types. Double double, in this case we have a string string, string type, and point type. Okay, now if I want to use this for, let's say, not point, but I want to use first type parameter as a point and the integer as a second type parameter, right? So like this, I have point p4 and p4 equals to summation point int p3, let's say 12. If I call is like this, then obviously this template will be instantiated. It will create its own version of the function with point as the first parameter, integer second parameter. It will pass, but the problem will come when we try to do addition of p3 and 12. Okay, the first parameter here is going to be it will try to do this, perform this addition, and that addition will invoke this function, and there is no function defined for the integer type as a second parameter here. So if you want to enable this kind of use for point type, then you need to create another version of this addition function for integer type as a second parameter. And in this case you need to define a logic. For example, in this case I want to, if I have integer type, I want to add that to only x coordinate. I just want to keep the y coordinate, just copy y coordinate and add the integer type to x coordinate. So this is a different function, and in this particular case it will actually call this function instead of this function. Okay, in this case, right now this will return the point type object, right, point type object. So we have insertion operator defined for point type object, so it should be okay to put in this p4 in insertion expression, right. So let us see the output. Now you can see the point passed was p3, which actually contained 3 5, and it was added the data 12 was added to it, which made 12 plus 3 15. Okay, switching back to the code, it is working. One additional thing, this is about having multiple type parameters. You can have 2, 3, 4, 5 depending on the requirement. There's no limit on the number of type parameters you want to use, and sometimes it's also possible that you can use a non-type parameter. For example, if there is a situation where you have to use some constant value, then I will actually explain that when talking about the class template. Okay. Now let me talk class template. So for class template, I'm going to remove all this code I have done here. Let me have a class to manage an array. I have integer array data 32. I want to have a class to manage this data. For example, to keep track of data count, to keep track of count of data. For that, I want to create a wrapper class. Maybe call this as a manager array to manage the data. Public default constructor count equals to 0. I'm going to make it as simple as possible to save time. Const int data and int count for count equals to CNT, and in the iteration in the loop I copy the elements one by one. I less than count, I plus plus. Data I equals to di. So let me make correction. This is going to be count. So in this case, typically you would also validate the data at this point, but I'm not going to use this class with invalid data, so I'm going to simplify to save the time. Okay, I'm going to have another function, print, to display the data. Let me display like this. So this will actually display the elements one by one, but it will put inside bracket, and this is for going back, so that the last comma character that was printed after data will be actually removed, or it will be replaced by this character. So this is the class I have, and I have, let me create int array data equals to 1 2 3 4 5 6, and if I want to use this array, I would create object, pass data and number of elements, and I call print function. So this is the class to manage the data, and we have this code to use that. Let me quickly compile it. So now the array is displayed. Okay, and if for example, if I have another array double of marks, let me have 60 61.1 71.1 and 81.1, 3 marks. And if I want to create another object, then I cannot use, because the type is different, so I need to create another copy of this entire array with only difference in the type, data type as double. And I think there are only 2 places I want to make change here. With this maybe I want to give a different name to it, maybe my array for int, and sorry, let me go back to the code. Okay, what I actually did was so I created a double array of marks, and if I want to use this similar array for marks, then I cannot use this array, because there is a mismatch of the type of the data expected in the constructor. So I need to create a copy of this array and change the type to double in these 2 places. With this I also need to have different name, so let me change this name to int and this name to double, and also make change in the constructor and here as well. So with this I should be able to use this double array marks and 3, create an md.print. So now we have 2 versions of the array with the same structure logic, but the only difference is the type here to manage 2 different type data. Let me execute this and show you the output. Now you can see the first array is printed, second array is printed with double data. Back to the code. Now if I want to minimize this code, like in the function pointer, I mean function template, I can create a generic version of these two classes like this. So I can create a generic version. Let me give name my array instead of my array integer. And to create generic version, you need to have keyword template, type name t, and you replace the type you want to be different in each case by that type parameter. That's all. Okay. Now with this, we have created a templated class template. If we have this class template, we don't need this individual versions of it anymore, because compiler will create these two versions. So we'll leave it to the compiler to do. And if I want to use this template class for integer type data, then you need to tell compiler you want to instantiate that for, right? This will instantiate for template integer type data, and for double type data you instantiate for double type data. So with this change, we have a template class, and we have the function to use, how to instantiate the template, and we can do the compilation and execution. The output is same, right? It's behaving in the way that there existed two different versions of the class, but there's only one version, right? So this is template class, this is generic class, parametric polymorphism, and all these things. And one additional thing is you can have two type parameters, and you can have a class to manage two arrays with two types data, different type. For example, if you want a single array to manage integer type array and double type array, then you can have like this. Or you can also have non-type parameter. For example, if you want to set this instead of setting to 32, you want to set that to a certain value. When you actually instantiate the template, then you can specify the type here, and you can put n here. So in this case, when you instantiate the template, then you need to specify the data that you want to pass there. Okay, it's going to be, for example, if I want to create an array of length, let's say 25, then you pass 24, you pass 24 here. In this case, I want that array to be able to hold 64 elements, then you pass 64 here, right? So in this case, you need to pass two, you need to specify two values of the parameter, one for type, one for non-type parameter. And this n is going to be used, and the size of this array is going to be as it is specified, right? Only difference is that the internal array that this object manages is going to be of maximum capacity of that array is going to be 24, and in this case the capacity of the array managed by this object is going to be 64, right? So let me write it down. In this case, this t is type parameter, and n is non-type parameter. Okay, back to the slide. So I discussed class template and function template. So this is the end of this video. Thank you for watching.